All right, hello, and welcome to our week 6 material here on getting data from the internet. So here's a good point in the course for me to talk about. Everything we've done so far has been internal Python things, right? So we put some data in a list of dictionaries, and then we kind of made a little business application based on that data, and we printed out that data. We asked for input, we added to that data, right? But we had to type all that data into the Python code, right? So in reality, in a business situation, we're going to get data from different sources. We're going to be using databases, files, communicating across the internet, and things like that. So what we're going to do is we are a number of things we're going to cover in the course over the next few weeks here. This middle part of the course is really about external data. What are the sources of data that we can bring in to our Python code and then use? Because it's a lot more fun if we have like a million customers rather than just three or whatever. So we're going to start with looking at how Python communicates with the web. So you know how you communicate with the web. You put a URL and you get a web page. So we'll start with that. We got a couple weeks of that. Some web servers are made to interact with software, and some are not. And so we'll look at the techniques you might use in those two scenarios. And then we'll continue on to reading and writing a file and reading and writing data in a relational database. So that covers some of the primary sources of data. So for right now, we're going to look at getting data from the internet with a Python request and a JSON object. And then there's going to be another video on this for when we don't have JSON objects. Okay. So, right, Python requests. You know how your browser works, right? You type a URL, the browser sends a request to that server. You get the web page back, and then the browser knows how to display that for you. The page that you get back from a server is actually not very readable, right? It's got all these languages, HTML, JavaScript, CSS in it, but your browser knows how to make it look good for you. So the request module is basically how we can put a URL into our Python code and retrieve that page, and that page is going to initially come back as a string. Sounds kind of weird, right? But it'll be a string with all of that information in the page. And that's kind of what gives us a challenge. How do you get information out of that? So let's look at import requests library. So I don't know how much I've talked about import. Import means we're going to add a library, which will have a bunch of functions, methods, data types, and things like that, or objects, more likely, into your Python code. So import request says, let's make the request module available to us. Okay. And then this is how we use it. Here, we make a variable called response. Response is kind of a standard for, getting the response back from a request to a web page, but really that response is just a made up Python variable name. That's a legal variable name, and we do uh, we call the request module and the get method, and the parameter, the argument we give to the get method is the URL of the page we want, and it goes and gets that page and it stores it into response. And we can do things like, so the response is now a request object, and that object has methods and attributes associated with it. So here we print the status code attribute of the response object, and we get back 200. So 200 is a response that means is the good response. 200 is the code that says we actually received a web page. So After executing this code, the variable response is of type request, and it has an attribute status code that tells us whether it was received correctly. That's a good thing to check, right? So when we're doing internet stuff, the internet's not perfect. Sometimes it's slow, sometimes it's down, sometimes you have an error, sometimes the server name changed. So check the 200 means it worked. I'm going to continue in this example, and I'm going to use a web page from archive.org rather than a direct web page. I'm just using that so that this demo always works. So another thing that happens when you use real web pages, the owners of those web pages change them. And so we're using a web page here out of archive.org so that it remains the same. Um, a couple things to point out here. When we put a URL in here, we use the %20 to indicate a space character. So the plain space character does not work here. So this little %20 is the space character, and we use that simply because the space character itself is not allowed there. So, but that sort of represents. Sometimes I'll point this out in the previous example. Sometimes when you see the question mark s equals something in the URL, that is actually kind of a variable being sent to the web page, and that's totally up to the web page receiving it if they have variables and input. Sometimes that web page receives that variable and gives you different information. So the variable s is being set to the value Holyoke, and the assumption is this web page knows how to deal with that. We don't know how or why. You have to investigate individual web pages. All right. Right. The data type of response is listed here. It's the class response. So the class response is defined in the module requests. The status code of 200 means that yes, it worked. Now, get the content of the response. Um, Here, the response has an attribute content. So that response that we receive back, it has an attribute content, and that has the whole web page in it, in that variable. But it is a data type bytes, and all that means is it's not really a Python string. It's just a list of bytes. Now, a byte, right, if we use an ASCII code, it could represent, one byte could represent the letter A. If we assume the digits in that byte are following the ASCII coding scheme, right? They could just represent a number, or they could, a byte of information could be anything as determined by the software that stored that byte. So here we're saying, let's make the assumption that they're, and it's pretty much true in this case, that the content of those bytes is regular text characters that Python would understand inside a string. So this data is take the content, decode it in UTF-8 is just a standard text method. So it's just saying each byte can be translated into standard text. So we're saying, yeah, though that code in there, that means the letter A, treated as the letter A. And by doing that, we bring it into the variable data, and now the data type of data is string. So we've just converted the content, which might not be valid text, but depending on the web page, but it often is, and we converted that to a Python string. So that's what's going on there. Now, now that it's a Python string, you know what to do to some extent, right? All the Python string stuff we learned before, anything you can do with string, data is just a string, and you can do all that stuff. But remember, it's a really big string. It's got a lot of stuff in there. It's got HTML codes. The HTML codes and tags, if you're familiar with those, are all in there. So we do a data find peanut, and that starts. Remember how find works? The answer is 119,000 because that's it. The 119,310th character in the string. Remember? So all our string stuff's going to work here. That's the main point. All right. So that's part one. Receive a web page as a string, and you can do string manipulation on it. String manipulation on a web page is, of course, difficult. Why? Because it's all that HTML codes. There are CSS codes. It's huge. It's not just the characters you see on the screen. So we're going to look at two ways of dealing with that. For now, today we're going to look at JSON objects. So within that response, if the web page wanted to give you data, they might have put it in a JSON object, so you do not have to use string manipulation. That's up to the designer of the web page. So a plain web page, you might have to use string manipulation. If you do have to use string manipulation, then you'll use the beautiful soup module, which is covered in our next video. So we're going to put that aside for a moment. And we're going to say, well, what if the web page gave us a JSON object? A JSON object is easy to manipulate. It's pieces of data, and we can put them into Python variables and just use them. So JSON objects is, so first, what is a JSON object? Let's look at that. Then we'll look at a web page that returns a JSON object. All right, so the JSON object, it's something that looks like, so we remember we used lists of dictionaries. Well, lists of dictionaries, right? That's taking, one data type and embedding it in another. And really, you could have a list of dictionaries, and one dictionary item could be a list, and that list could have dictionaries, right? We can nest those data types within each other to any depth we want. And that's basically what JSON does. It's just any combination of lists and dictionaries and things like that. The thing that's different from a JSON object and a Python list of dictionaries is that it has quotes around it to turn it into a string, basically, right? So it's when different computers of different data types and different languages communicate, well, most computers know what a string is. So when we send data from one computer to another that uses a different programming language, we might send it as a string because we know that computer can receive the string. And then when they receive that string, they can decompose it, rearrange it, the data in it however they want. So JSON is at the heart of it, the object is a string, so we can transfer it between machines. But then inside it is the definition of lists and dictionaries and things like that. So the JSON module in Python is when Python receives this JSON object, JSON converts it into native Python objects, the strings and dictionaries, and then you can just use all your regular string and dictionary methods to take that apart, analyze the data, or whatever. All right. So let's jump down to an example. So there are two things we will use quite often, and that is JSON loads and JSON dumps. Basically, these are going back and forth between a JSON object and the corresponding Python object. So we receive something from the web, it's a JSON object. We can't really do anything with a JSON object in Python. So we convert the JSON object to Python objects, then we do our stuff. And if we needed to send it back, we might convert it back to a JSON object and send it back. So JSON is really just, kind of for that transfer. But within Python, we'll put it into native Python objects. So to convert, we receive a JSON object and we convert it to a Python object with JSON loads. And then if we have Python data and we want to put it back into a JSON object, we can use dumps. Here's an example, right? Here's the example. So import, right? I mentioned that before. We need the JSON library, so you got to import that at some point. Usually you put imports at the top of your script. These are broken up because of the way the lecture goes. JSON data. So JSON data here, and actually this is not PEP8. It's supposed to have spaces around it. Some of this, a couple of these examples, I copied and pasted, and they don't have the PEP. But make sure you do PEP8. So look at this. It looks like a list with square brackets of dictionaries, right? Because the thing inside the list looks like a dictionary. Um, but it has a quote outside it. So JSON in line 3, the data type of JSON data is a string. It's just a plain string because it's in quotes. But the information in that string um, is compatible with lists and dictionary notation in Python. So what we do is uh, we have a string, and then we do execute the JSON loads method on JSON data, and the JSON data is now converted to Python data. And the Python data is actually a real list. Now this is kind of funny to this is kind of funny to read. This is a list. The list, and again, here's something, we're gonna get a lot of these data types embedded within each other, and you're gonna take a moment to dissect what's going on. The outside bracket means it's data type list. Well, a list is a bunch of things separated by commas, but this only actually has one thing in it. The squiggly bracket to the squiggly bracket is one thing in that list. So it's a list of one item. And with that one item is a dictionary. The dictionary is also has things separated by commas. So it's a dictionary with 3 items in my dictionary. Okay, so we can embed lists and dictionaries in any level of nesting. Um, now, so this is what a JSON object looks like. It's a string for easy transfer. JSON loads turns it into Python data. The Python data type is a list with a single dictionary in it, but you can have any size thing. All right, and so that kind of explains what I said verbally. So let's see. Here, let's go to look at a bigger example. Well, this little short example here, where we do Python JSON data equals um, JSON dumps Python data. So, like sometimes you edit data and send it back to the web server, right? So we convert it to Python. We maybe edited that list, convert it back to JSON. Now we have a JSON data type, and that might get sent back to the web server if the server would accepted that. But I want to go with this JSON data type here into a little more detail. The variable quiz, just a Python variable name, is assigned the 3 quotes. I'm not sure if if you've seen this yet, but the 3 quotes just means an extended string over multiple lines. So the 3 quotes means that we're not going to find the ending of the string on the same line. It's going to go over multiple lines. Similar to the doc strings. A doc string is just a multi-line string that is not assigned to a variable. This one is. So quiz is a Python data type string. The information in that string is a valid dictionary of dictionaries of dictionaries of dictionaries and eventually a list. So multiple embedded uh, uh, dictionaries and lists in there. So that's what makes it a JSON object, a string that could be, you could imagine converting it. I'll just point out right down here, the triple quotes is the end of the string. Again, you're going to have to kind of really pick your way through this slowly to make sure you know what squiggly bracket goes with what squiggly bracket, right? It's kind of a mess. The way this was typed in is helping you out, right? So look at how the indentation is done. The indentation is not relevant to the computer. Python doesn't care about this. The indentation is to help the human figure out what's on the screen. So we're starting with a dictionary. That dictionary has a key of quiz, and the value of quiz is all of this stuff, right? And so quiz, the main dictionary only has one thing in it. Right? The only thing in the main dictionary is one element called quiz. But that element quiz is in itself a dictionary. And it's a dictionary with two things in it: sport, which is a dictionary, and maths, which is a dictionary. So quiz is blah, blah, blah. When we access this data, right, here's the tricky thing. How do you get at that data? So this would be the results we might get back. You might be a web page that says, this is a quiz making web page, right? And you did a request, and in the response was a JSON object, and you said, and the web page generates quizzes for you. Great. What do you do with that data? Here we go down to that, right? Import JSON. We need our JSON. Normally, don't put so many imports, but it's kind of for demo purposes to make sure each section works here. Python data. JSON loads quiz. So quiz was the response we got from the web server. Python data converts quiz from JSON to a Python object. And look at these print statements, 5 through 10 here. This is how we navigate those embedded dictionaries, right? Print Python data. That's line 1. Well, that's just the whole thing, right? Blah, 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 down here. Print Python data quiz. That says go into the dictionary and find the quiz element. And that's on line 2. So, right, quiz was the first key in the dictionary, or the only key in that dictionary. And the content of that key was another dictionary. So line 5 writes the word quiz. Line 6, the word quiz isn't there because we're only printing the quiz dictionary. Within the quiz dictionary, so look for the sport key in that dictionary, and now we're only looking at questions about sports at this point. Within the sport dictionary, there are multiple questions. So anyway, go through this. Be careful. This is why you just kind of have to be careful. If you're building something complex, you might do it in pieces. And if you're taking apart something complex, take it apart in pieces to make sure you're piecing through it in the right way as these get complicated. All right. So, blah, blah, blah. Having said all of that, that's what a Python JSON object is. Here is an example of a website that returns a JSON object. So that JSON object was just kind of by itself. Now we're going to say, what happens when the JSON object is returned from the website? And here we go. API. So this is just putting the URL in a variable, importing request, imports usually come response. So this is just put the URL into a string variable. Might be convenient to do that So we're going to see in a second, if you put the URL into a string variable, you can use string manipulation to create the URL. So here's the key, right? Blah, blah, blah. Look at this. In this level of the URL, see how it says AAPL? This URL is going to give us data about Apple. Now that's totally unique to the way they designed this page. So when you're using this, you have to know that. But we could put different tickers there and this would work as well. So that's the key thing. But let's just work with it with Apple. So that's the URL. We do a guess. The response here is different because we put the .json on there. So that gives us the JSON information that was returned to us in the request, right? So last time response equal request.get, and now response equals request.get.json. So we get the JSON portion of the web page, not the whole web page. And here's what it looks like. Ticker, Apple, results, values, blah, blah, blah. Again, these are sometimes difficult to interpret. Sometimes a web page might document how they designed their JSON file. Sometimes a web page may not document it well. And then exploring the API call, right? So if this format was not documented well on the web page, which it might not be, I could do. I know. I've taken my response. It's a JSON object that has um, that's a dictionary for key and response. I can print the keys, and the keys are telling me what dictionary items I have in the response. Here I kind of break it down, right? Response. Here's the whole response. The whole response looks like a dictionary. Um, the results piece of that has values, so it's the stock price at different times, right? So now, if we put the idea together that we put the ticker symbol, now we know this web page, the ticker symbol is part of the URL and tells us what ticker symbol we're going to get receive data on. Now I've made a function to do this, right? I'm making a function. Why? I want to encapsulate the idea of getting a response from that website so that now, if we think about it, an input to my function can be that APPL, right? Back the URL had APPL in it. Well, why don't I simply make that an input to a function and have the function build? Look at this. Embedded, right? The plus is just string concatenation. So we take the symbol that somebody put as an argument, and now we embedded that in the URL, right? This is the new URL. We get the JSON object for that URL, and we dissect that and get just the ticker information and send data back to the main program, right? So this is what I mean by embed the complicated things in um, functions and classes, right? We went to this web page, we figured out how it worked. There's a bunch of weird things we have to do. We have to put none of it makes sense necessarily, right? Because it's just unique things to that web page. Once we figure that out, encapsulate it in a function, now this function is great. We call the function stock summary, and we give it a ticker symbol, and we get a stock summary back. Pretty straightforward. And look here, so we might have some variables, stock, start date, end date, and then we run stock summary, stock start date, end date, and we get an answer. Apple is $130 on that date and time. Now, see how useful it is? So The website had data about stock prices on dates and times for different symbols. The URL to get that information is kind of long and weird. Therefore, we embed the creation of that URL in a function that we wrote that is easy to use, right? Look how easy it is to use. Stock summary, stock, blah, blah, blah. And the answer is Apple, the ticker symbol, and a price, right? We made something complicated easy, and that's why we have functions and classes. We want to take something weird we figured out. In a corporate environment, you might have a bunch of these shared in your organization. In fact, and then so now that this function is easy, we could use it over and over, right? So make a list of all the stock symbols that you think are interesting. Apple, Google, Microsoft, GE, right? Start date. And then for I in stocks, right? Well, stocks is a list of tickers. If it's a list of tickers, we can run stock summary on every single one of them, right? For I in stocks, use I with our new stock summary thing, and we append the data to a list. So table is a list. Each time we get an answer to that list, answer to that stock summary, we append the answer to the end of our table, and then we print it out. And look, so we made this. Think of it. Remember the input function? We could say, "Hey, what ticker symbol are you interested to our user?" And they might type that in, and we might call our function, or which multiple things and things like that. And then maybe we go, maybe we're doing data analytics on the price of Apple for the past 3 weeks. So we run this and get the closing price every day for the last 3 weeks, and we do regression analysis. Does that fit our regression model or whatever? So today was um, getting a web page. The web page goes into a string. That's hard to use, but we're going to look at that further in the next video. Um, some web pages return a JSON object. The format of the JSON object might be easy to figure out or difficult to figure out. The designer of the web page could have made that complicated, and they may or may not have documented it, right? If it's just for their own use, they might skip the documentation or might not make it public. All right, well, thank you. And that is receiving a JSON from the web.